Imagine looking up at the night sky and seeing Betelgeuse, a colossal red supergiant star nestled in the Orion constellation, suddenly burst into a spectacular explosion. This event, a supernova, could be visible for weeks, possibly even brighter than the full moon, casting a brilliant light that might dominate the night sky and be visible even during the day. Betelgeuse, one of the most studied stars in our universe, has captivated astronomers and stargazers for generations. Its massive size, combined with its proximity to Earth, places it at the forefront of scientific curiosity regarding the life cycles of stars, stellar explosions, and the intricate processes that shape our universe. Betelgeuse, also known as Alpha Orionis, holds a prominent position in the Orion constellation, which itself has a legendary place in ancient mythologies. Orion, named after the mythical Greek hunter, is one of the most recognizable constellations due to its arrangement of bright stars, including Rigel, Saiph, and Bellatrix. Betelgeuse, located in the top left corner of Orion's distinct figure, marks the shoulder of the hunter and is the 11th brightest star in the night sky, fluctuating in brightness due to its classification as a semi-regular variable star. The star's distinctive reddish hue and the fact that it's nearing the end of its life make Betelgeuse a prime candidate for an eventual supernova event. Astronomers have long speculated about when this supernova might occur, but in cosmic terms, it could happen anytime within the next 100,000 years. This relatively short timescale has prompted intense study of the star's behavior, and any anomalies, such as Betelgeuse's unexpected dimming in recent years, have spurred discussions about whether we might witness this extraordinary cosmic event in our lifetimes. The recent dimming of Betelgeuse in 2019, known as the Great Dimming, raised significant concerns about its fate. For a star that typically fluctuates in brightness, the sudden drop of around 60% in luminosity was unexpected. This event attracted the attention of astronomers and astrophysicists worldwide. Many initially speculated that this dimming was an indication that Betelgeuse was about to go supernova. However, further observations revealed that the dimming was caused by a massive ejection of material from the star, which formed a dust cloud that temporarily obscured its light from Earth. While the dust cloud has since dissipated, Betelgeuse has not fully returned to its previous brightness, and its 400-day cycle of brightness variation has shortened to just 200 days, indicating ongoing changes within the star. The significance of a potential Betelgeuse supernova cannot be overstated. Betelgeuse is a red supergiant, one of the largest and most massive stars known to science. Its mass is estimated to be around 10 to 20 times that of the Sun, and its size is approximately 700 times greater. If Betelgeuse were placed at the center of our solar system, its surface would extend past the orbit of Jupiter, engulfing the inner planets, including Earth. This immense size is one of the reasons why Betelgeuse is in the final stages of its life. Red supergiants, having exhausted the hydrogen in their cores, fuse helium and heavier elements in a desperate attempt to sustain themselves. Eventually, the core will collapse under its own gravity, leading to a catastrophic supernova explosion. When Betelgeuse finally goes supernova, the explosion will be one of the most dramatic events visible from Earth in recorded history. Supernovae are the final, violent death throes of massive stars, releasing an immense amount of energy in the form of light, heat, and radiation. The explosion of Betelgeuse would send shock waves through both the scientific community and the general public, sparking awe and wonder as people around the globe witness a star's death. Unlike most supernovae, which occur in distant galaxies and require telescopes to observe, Betelgeuse's proximity to Earth, estimated to be between 500 and 650 light-years, means that its supernova would be visible to the naked eye. For weeks, perhaps even months, the night sky would be dominated by the brilliant glow of Betelgeuse's supernova, outshining all other celestial objects except the Sun. The explosion would be so bright that it would be visible not only at night but also during daylight hours. It would rival the full moon in brightness, casting shadows and illuminating the Earth in a soft glow. This incredible display would gradually fade over the course of months, leaving behind a neutron star or potentially a black hole, depending on the exact mass of Betelgeuse's core. The study of supernovae, particularly those as close as Betelgeuse, offers scientists invaluable insights into the life cycles of stars and the evolution of galaxies. Supernovae are responsible for creating many of the heavy elements in the universe, including those that make up planets and even life itself. The explosion of Betelgeuse would release vast amounts of elements like oxygen, carbon, and iron into space, contributing to the cosmic enrichment of our galaxy. This process, known as nucleosynthesis, is one of the fundamental mechanisms by which the universe evolves and diversifies its chemical makeup. Additionally, Betelgeuse's supernova could have profound implications for our understanding of stellar physics. Despite decades of study, many aspects of supernovae remain shrouded in mystery. The exact mechanisms that trigger the collapse of a star's core and the subsequent explosion are still not fully understood. Observing Betelgeuse's supernova in real time could provide crucial data that would help scientists refine their models of stellar evolution and death. One of the most intriguing questions surrounding Betelgeuse is how its supernova would impact Earth. Fortunately, despite its relative proximity, Betelgeuse is far enough away that its explosion would pose no direct threat to our planet. The radiation released during a supernova, including gamma rays, would not be strong enough to cause harm at a distance of 500 to 650 light-years. However, the event would still have significant scientific and cultural ramifications. It would be the first time in modern history that humans have observed a nearby supernova, offering a rare opportunity to study the aftermath of such an explosion in detail. The history of Betelgeuse is as fascinating as its potential future. Ancient astronomers from civilizations such as the Chinese, Romans, and Arabs recorded observations of the star, describing its color as yellow or orange. This historical discrepancy with modern observations, which identify Betelgeuse as distinctly red, has led scientists to speculate that the star may have evolved rapidly over the past few millennia. A shift in color from yellow to red could indicate that Betelgeuse has progressed from an earlier phase of its life cycle to its current status as a red supergiant. If true, this rapid evolution would provide important clues about the timelines of massive stars and their eventual demise. The possibility that Betelgeuse could explode at any moment has also inspired a range of scientific simulations and models designed to predict the appearance and behavior of its supernova. These simulations suggest that when Betelgeuse explodes, it will shine with a brightness comparable to the full moon, possibly even brighter. The light from the supernova would likely reach Earth within hours of the explosion, as the star is relatively close by cosmic standards. The supernova's light would be visible across the globe, making it one of the most widely observed astronomical events in human history. In preparation for this event, astronomers have been closely monitoring Betelgeuse using a variety of instruments, including ground-based telescopes and space-based observatories like the Hubble Space Telescope. These observations have revealed fascinating details about the star's surface and internal processes. Unlike the Sun, which has a relatively smooth and stable surface, Betelgeuse's surface is a chaotic collection of massive, boiling gas pockets.